All right. Ariel's convinced. She likes it. She quickly realizes that her on her own with NSO on her laptop is not good enough. She goes to her boss and says, we actually have to build a little bit of an automation team. And I would strongly suggest we get someone with a passion for scripting and understanding how to actually build systems in Linux environments, right? So they hire Erik. Erik is tasked. He goes to work every day making sure that the actual automation framework is zippy and feels good about itself and does what it's supposed to do. Again, these are one of the kind of hard-found truths that we have seen many network teams go through, is that they rapidly need other types of talent than purely understanding the networking magic. He's tasked with making the disparate infrastructure that is everybody's network to look like something cohesive, look like something you can actually consume, to look like something that you can ask to do things for you, instead of a distributed set of disjunct and weird protocol-speaking pieces of hardware or software. He builds a tool chain, and he's very proud of it. And we are really working hard to make sure that when the Eriks of the world think about network automation, they think that NSO is the greatest thing since Ansible, I guess, since Terraform. Here's what he likes. I mentioned this before. NSO's database is built on an actual two-phase commit-based transaction engine. I was talking about that. We need to be able to go
again? Sorry, I totally missed.
I'm going to go even faster. Thank you for doing that. So it's built on what our database brethren would call a two-phase commit-based transaction engine. So it is the fundamental promise from the data layer to the user that either the entirety of what you just told me to do is successful, or I can provably take you back to where we started. I will not leave you in a half-baked state, which otherwise is the is the problem with many of these solutions in networking, is when they run into something complicated, they give up and say, bring in the CCIE. The 3Com wizard, please, needs to go in and undo things, both in the database, in the SQL database, and in the device themselves.
That's a very old reference.
I know. I try to sneak it in there.
I appreciate it. Did you get paid to put that in there?
No, I didn't.
Okay.
No. Well, I pay myself. Weird credit stream going on. So what this means is that, again, we really want that database feel, right? You shouldn't have to be a licensed network engineer as you interact with NSO. With that transaction engine comes a couple of constituent parts that's actually pretty useful. I mentioned trust, right? So what Dimitris showed several times is what we call dry run, meaning show me the exact ordered sequence of operations or commands that you're about to send to my network, because I want to see it for the first 150 times, and I'll forget it once, and I will trust this system. And again, rollback capabilities. With that kind of Delta-based database, we can also expose something that kind of resembles Time Machine. If you guys I see a lot of Apple products. You can actually go back and forth in time in the configuration of your network, right? You can either go backwards through deltas or pick a delta from history and I try to apply that. So it gives a very nice time-based as well. And again, I don't want to bore you too much with Yang. I do that habitually otherwise. But Yang is a very expressive language. So there are basic types for example, IP addresses. There are basic types for referential integrity from where you configure an ACL and where you use it. So we can avoid dangling pointers. So it gives you a very strong schema. Yeah.
Just to expand on that, Yang is all those things.
Yes.
But it's almost too much of those things.
Yes.
It's a bit like,
yes,
CMIP was. Right? So the question there is, have we seen networking professionals start to look more positively at Yang, or do they not care because it's just embedded inside of something like NSO?
I think for the people below the surface, which is NSO and down, it's Yang.
Yeah.
But I will give you that maybe because no alternative.
Right.
And maybe because more than incrementally better than SMI.
Yes.
Or the SMI-NG.
Or gRPC or
exactly.
YAML or whatever.
Yep. Above the fold, the people that consume, they don't want to hear, they shouldn't hear about Yang.
Yeah.
That's where you get Terraform language, Ansible modules, Swagger.
It's like arguing about what assembly you're using to compile your code.
There you go. Yeah. Never mind. We do see with some glee, though, that JSON schema version 3 took a gigantic step towards becoming as horrible to implement as Yang.
Okay.
With type systems and all that kind of stuff. That's hard. So there's nothing that is obviously much better, in the many dimensions.
I'd love to find out what idiot came up with Yang.
Did you
I'm messing with you. Sorry.
did you hear why we named it Yang? Super ironic, yet another next generation. People love this yet another and the next generation, so we said just take out the middle, just call it yet another next generation.
As opposed to YAML, which is YAML ain't a markup language, which was just like a big finger to the world. Yeah.
Alrighty, what we also saw from Dimitris, which is actually something that can be a little hard to explain before we show it, is this referential integrity. It is the fundamental understanding of looking at any line of configuration in a box. Did this come out of someone just putting it there, or is it the result of a service? And the other way around, looking at this service, what is the exact configuration parameters that have been spread out over the network to fulfill this? This is truly at the heart of doing cool things, because this also means that you can or could, in a demo, move, for example, VLANs across vendors. And all NSO does is that it recomputes the create side of the service, and out comes both what needs to be removed and what needs to be added, just by moving the referential pointer between devices. That, my friends, is an awesome superpower to have. And it also means that if someone changes something out of band, you can rapidly see, does this configuration belong to a service? Therefore, is it likely that that configuration change will actually mess with an application or mess with a subscriber? So that pointers going back and forth is at the heart of many of the superpowers that NSO has. Layered service architecture. This one comes up really early. I have a very large network. You can't run one instance, right? We have customers that have the excess of 100,000 routers under configuration control for NSO. So we have something called layered service architecture. Very large customers have what we call lower node NSOs in each of their footprint. So Western US, maybe Central, maybe Eastern. And then they have an upper node that actually carries the services. So it becomes like a sharded database, for those of you who spend time in database land, of the configuration of the services and the operational state of the device. This one came up when we crossed, we usually say that every order of magnitude carries its own set of problems. So we got along fine in single instance up to tens of thousands of devices, but about 100,000 devices, you start seeing really weird problems because none of them, they are misbehaving to various degrees over time. You always have a percentage of boxes that acts like they don't want to play. So we needed some sort of sharding so we could constrain the issues to 2 domains. So this came out pretty nice, and you actually have local access here. So if your team, works on the East Coast footprint, you can either go through the local NSO, or if you're so inclined, through the Northbound NSO. And normally, of course, above this NSO is your provisioning or flow-through provisioning system.
So that's how you've scaled to service provider class networks.
Yes.
So tens of thousands of devices.
Actually, we have a customer with more than 200,000 routers in India.
And so the enterprise version of this is going to be the same, but just you have less instances.
That's right.
Logically, right?
That's right. That's right.
Are you going to change the feature set to be enterprises often struggle to have independent thought or to cope with, complexity, too much complexity. If they have to do too much work, they may fall at the hurdle sort of thing. Are you going to do something about creating some opinionated approaches or an opinionated introduction so at least people can get on?
That is most of what Omar and I do these days is that. And it's a big shift for us.
Yes.
It is a big shift because, as you well know, when you talk to our service provider brethren, they will tell you what color they want the box to have, right?
Yeah.
And it's not going to be like anyone else. And moving and working more with the enterprise, the expectations are the opposite. Well, you tell me.
Yeah.
And we go service provider style. We don't know. We're
Don't
just
you know?
people.
You should know your network. You should know how you operate.
There you
and
go.
they often don't.
And to a surprising degree, they don't. Right? So we are asked to lean in. So we're doing a lot of stuff actually around that. It's fun. It's actually pretty cool.
Yep.
Demo time.
Okay, so I would like to touch on a couple of points that Carl made earlier. So I'm back in the demo. We're looking at the configuration viewer of a particular device. And what I've done here is I've selected the service metadata button, which shows me the ref counters that Carl mentioned. It's what NSO keeps inside its CDB to keep track of referential integrity. This piece of configuration belongs to that customer, belongs to that service, is applied to that type of device. So anytime NSO performs an action, we'll actually look up at these counters and make decisions based on the information that's included here. The other thing that Carl mentioned, and I want to demonstrate to you quickly, is what if I need to make a change suddenly for whatever reason in my network? I was using, for instance, a particular VLAN 500, but I realized that that's going to clash with something that I'm introducing into the network, and I need to change it. I have to go around so many devices, but NSO will do that for me in this case. So NSO now is going to render again the service, find where that 500 ID, VLAN ID, was applied, and introduce the change for me. Okay? I won't push it into the network. I just wanted to show you how easy it is to update configurations based on dynamic changes that evolve in your environments. NSO will take care of figuring out the configuration.
Does it do any threat modeling or risk modeling to figure out how this will actually impact the network from a usability standpoint?
No.
Okay.
We have various integrations with systems that do that really well, but it's not a first-class feature of NSO.
Okay.
So that's a great example of something where the interaction between this type of abstraction and more specialized systems it becomes really valuable.
I'm not going to apply this configuration. I'm going to revert it. The other thing I want to show is the ability to go back in time, as Carl mentioned. So I will show some configurations that have already been applied into the system. NSO not only stores the current state, it stores also the previous state, so I can return to one of those. There's the configuration I just applied area where I deleted switch number 1, just before that I deleted the interface. I can load that back into the system and reapply that configuration. So those are all stored within NSO. I'll revert that as well. And the last thing that I wanted to show at this point for this part of the demo is, I'm going to simulate now a situation where somebody ad hoc would go and break something into the network. So let's say somebody goes to one of the switches, one of my spine switches. Once I can type, and makes a change. If I go back into my environment, that causes a problem in this topology, in this service. What I can do with NSO is I can go into my service manager, select that particular service that I'm running, that you were looking at the UI, and I can ask NSO to check the sync, go to the devices, and tell me if everything in my environment is as my service intended it to be. You can see it came back with a red answer, something is wrong. So I'm going to query now the network in comparison with the service and find out what has been changed. Once I've identified what's wrong, I can redeploy the service and bring it back to a working state to where I wanted it to be originally.
So now you've manually done this check. There's many examples where you don't actually know you've done something wrong, so you're not going to go in.
Three approaches. One is certain types of equipment can tell you that something changed. So it sends a trap or inform or something else. Mm-hmm. So you kick this off. Some people run this as part of their maintenance window, and they produce reports. And yes, some of these reports also point to the username of the person that was logged in at the time, so that you get that full blame chain. But we also find that's another excellent example of an area where people have wildly differing opinions on how it should be done, right? So we're trying to be a good process citizen and conform to, well, the three most popular ways of doing it.
Okay.
So once I've redeployed the service, I can now check again, and it will come back as green. I have affected the change into the network as it should be originally. I'll be talking now a bit about the programmatic interfaces that are available within NSO and how you can interact with the tool without actually using NSO itself. So Northbound, there's a number of APIs that are available through NSO. Every time you create a service within NSO, the APIs are rendered automatically for you. So the services are exposed in any of the languages that I'm showing here. I'm going to start by showing you a couple of examples using Postman, making a number of REST-based API calls into NSO where I can query the system. When I can effect a change, I will even augment the service that I showed earlier.
Let me say this actually. So maybe here's the point we're also doing by looking at this from various angles, is that NSO is at its core a database that reflects the configuration and operational state of the network. Then there are many ways and means to navigate, update, and commit changes through NSO. So all these Northbound interfaces, all they do is to expose the same data structure that sits in the database, and it allows you to make, and this is important, arbitrary changes to it, right? You can change just the VLAN or the configuration of NTP for 30 devices and the VLAN and move a VPN at the same time. It is a set of data that represents the network, and you're supposed to be able to do anything you want to it inside of what's defined by the Yang modules.
So I will switch now to my Postman interface. I have a number of REST calls that I've prepared. First one is I'm going to query the system, and it should tell me how many customers are running on. Right now, I only have Acme. I will create a tenant. I'm using a number of variables within Postman. The only thing I'm setting in stone is, the route distinguisher for this example. I will push this into the system, and I switch over to NSO and refresh. I'll notice that I have now a new tenant called Made by Postman, just to illustrate the point. If I click on Made by Postman at this point of time, it has no resources allocated to it. Again, I will switch back to the Postman interface, and I will assign a switch, an interface to a switch to that particular customer. And now you can see that I have selected switch number 1 and assigned it to the 2 switches. It has configuration, in the 2 spines. I can also delete similarly, but I won't do that at this point of time. I'm going to move to the next tool that I want to show you, and that's Ansible. In this particular case, the way that we interface with NSO, we have modules that are built in Ansible. They're available until its release version 2.5. There are 5 modules described here, and they allow you, again, to interface with NSO and perform any kind of action by, either withdrawing information, data, or affecting changes into the network.
And here's what's maybe important is to understand that, no, given environments where NSO manages the network, all you will ever need are those 5 Ansible modules, because they constitute the basic verbs: read, create, update, delete, right? So that's all you need. Independent of you have 12 vendors, and this is a multi-domain thing, this database is what you're interfacing with.
So 4 network engineers hop onto the console at the same time and queue up a series of changes that are all different, pushing to the same devices, and all hit go at the same moment. What happens?
So we actually have a collision detection in the system. There's actually a critical section, inert and transactions. I'm trying not to go into the weeds too much here, but NSO's CDB is something called a point-in-time consistent database. So we have to, at all points in time, uphold the promise to say no data in this data store at this point in time is invalid according to the Yang. So we actually take a critical section, lock, and we serialize the changes. If they're truly parallel, meaning they provably don't touch the same subtree, for example, of configuration in a device, then we can do it in parallel. But normally that giant lock provides a sense of security that many of our customers like. So they would rather take the performance hit, but have a fully transactional system than do it in parallel.
And if there is a collision, some kind of a competing change, you're going to put it into a particular order, and however it gets serialized, the last change is going to be the effective one.
Yes, exactly right. Yep. It kind of resembles the way Subversion does things, for example. So it's not something we invented. It's a pretty common pattern.
Okay, thank you for that, because it gave me time to fix something that I realized was wrong.
I was there for you, yeah.
Pointing to the wrong system.
What a professional.
Anyway, so we have here a simple playbook written in Ansible, and all it's actually now going to do is going to create a tenant for us, made by Ansible, and it's also going to make some changes in the data center. standard Ansible stuff, the system that I want to attach to, the credentials that I'm using, and I'm just going to highlight the portion of the code that's going to affect the change in the environment. We're utilizing here the NSO config module. And
let me actually say here, let me say that the thing to look for is data. That's actually the top of the data tree in NSO. In this case, we move into the services side of NSO. So this will obviously configure stuff in the services side. But this could also have been a device, right? So the device tree would have said devices, device, name of the device, and then the config. And that's the whole point here. We manipulate the data in NSO, independent of whether it's device-specific or services. And NSO figures out what to do towards the network based on it. So it puts what we believe the right pressure and the right task in the right hand.
Just going to give it a name. And I heard earlier that we're calling FTD 20. So again, the effect of this is that it will reach out to the NSO system, push the configuration to NSO, and ask for it to create a tenant with a particular name and assign some resources in the data center to that particular tenant. So again, if I switch over to my NSO system, refresh my screen, I also have now made by Ansible FTD 20.
Just the FTD20, but...
Yeah, that's the only thing I added now dynamically. The rest of the name was created earlier, so I can distinguish between the tenants.
Now, has that been committed at this point?
Yes,
Okay.
This is already in the database. It has affected the systems in the infrastructure.
Okay.
Okay, and from an Ansible standpoint...
Don't you want it to?
No, I was curious. I didn't see anything in the config, in the template saying whether that was a go do this and kind of stage it or action it straight away or other. So
Right, there's a certain metadata that you can use to decorate the module tasks.
Okay.
So you can tell it to do it in various fashions.
And this is the way that we actually interface with NSO through Ansible. As I mentioned, we do have the modules. Last but not least, Terraform. Terraform, unlike NSO, is a system that maintains state, so it's not a fire and forget. You actually create a Terraform config file. You need to create a schema so that Terraform can store the information within its structure. And the way you do that is by creating a provider. You create a provider which targets a particular system, and within that provider you need to define the schema. So if Terraform is talking to AWS, it has all the constructs that reflect what happens in AWS. But they have to be hard-coded in the provider themselves. With the provider that we've created for NSO, we do it dynamically because everything in NSO is Yang-based. All we do is that we point to the Yang file that we want to render inside Terraform, and it automatically creates the structure for us. So it's extremely dynamic. Every time you create a new service, a new Yang model, the provider will pick it up and create the appropriate structure and store data within Terraform. And this is basically what it looks like. We have the NSO system, we have the services in NSO, they're all in Yang. The provider will pick up the Yang files, pass them, and create the appropriate schemas for Terraform. So let me just go to the Terraform system. And again, at this point of time, I'm pointing to Yang variables dynamically just for the purpose of the demonstration. This is the information that I have in my Terraform config file. I'm doing something very simple. Again, details about the system that I want to interface with, credentials, and what I'm actually trying to affect here. So I will start by doing a Terraform plan, and this is actually asking Terraform to evaluate whether everything is okay. I need the init first, then I can do the plan. Yeah, so this one went wrong for some reason, and it was working earlier. I'm afraid I'll have to stop at this point, but...
Live demos.
Yeah, I can fix and hopefully show it at the end if we have some time.
Yeah. Guys, the point we're trying to make here, of course, is with a formal way of describing to the rest of the world what the network can do for you, we can with ease actually translate that into whatever tool of choice our customers have, right? And again, we think this is a fair way or the networking to turn up inside of the tool chain of choice, independent of whether you're a OSS, BSS geek in a service provider, or whether you own large swaths of application operations and you live and die by Terraform. And it doesn't under-optimize networking like many other approaches do, only showing little pieces of it, right? And usually vendor-curated pieces. NSO actually allows you to see the entire network across all vendors down to the detailed configuration through Ansible or Terraform, if you so want to or feel like it, which is a big thing. We're also part of, thank you. We're also part of, so we work closely with Ansible for a while now, and as some of you may know, if you have an Ansible interest, Ansible is switching to something called Ansible Collections, and we're going to be one of the first, what's called certified collections. So we're going to stick by them and work closely with them. There are a couple of use cases that we solve beautifully together, so we do spend quite a bit of time and resources with making sure that we are up to speed and up to snap with our buddies over at IBM Red Hat Ansible. Alrighty. My favorite, the service developer, someone with an actual software portfolio or software toolkit with them. We've had a hard time recruiting these people into networking because the amount of, well, they normally or historically had to abandon everything they know and learn things that they probably don't want to, like SNMP, like all the various ways we had to go and invent to make ourselves look different than any other part of the IT infrastructure. Now we're getting better. So we're getting to see people actually flooding in, and most of them are at least curious to see what networking can do for their career and for their application. So it's usually a good conversation to have. Here's how software people think. If any one of you have been a programmer before, there will be no surprises from here on. It's news to many people in networking. You want to be able to define the services that you develop using programmatic means, machine-readable things. This is where we think Yang is the best option. Just because you get one service or one instance of NSO into production doesn't mean you can go home. That's usually where it starts. So there's a rapid iteration of the life cycle of the assets that runs in NSO. And oh, by the way, of course, you upgrade your network, you introduce new vendors, so things continuously change. That needs to be a solid part or solid architectural principle for whatever toolkit that you use here. We want to slot in the development and management frameworks, again, that these people already know and love, right? So don't introduce any new editors, don't introduce any new build tools or anything like that. Make sure we're a good process citizen in a normal software development tool chain. So what you could say also is minimize the amount of negative surprise for software people as they try to make their way into networking. And again, I keep coming back to this because we truly think that this is the game changer. If you define the service and you define what a create side of a service means, NSO will figure out the rest. And again, this is really where it takes off. Create, any system can do that. If you're skilled with Jinja 2 and some Python, you can put together some templates. It starts to get really tricky when you want to update things. Dimitris showed how to update a VLAN across a number of devices by figuring out how to actually go into that configuration and make a minimal diff. And delete actually turns out to be one of the tougher things to crack, right? The canonical example is bringing down a VLAN or removing a VLAN on an interface doesn't necessarily mean you can power down the interface. There might be other customers or other applications using that interface. So you have to have some form of reference counting and some sort of resource view so you know that only when the last VLAN exits the interface can you actually power it down. Repair actually comes in many shapes and forms, normally because of break fixes that actually impact services. So as I mentioned before, redeploying, or actually as Dimitris showed, redeploying the service to make it sure that the configuration integrity on the devices are whole and that it behaves like it's expected to is also a very important part of this. And again, exposing this to the users, independent of whether they use the Java bindings, Python bindings, the REST interface, or for that matter, the CLI, so that they can arbitrarily perform these operations across the data set is of course key here. Again, another slide of no surprises if you're a software person, right? You need to install applications. You need to install packages. You need to update the packages. You need to have some sort of version. You need dependency resolution. Some packages are going to be dependent on others, right? You need to understand that if I upgrade this may pull changes from other packages. You want to be able to bundle things. So if you have a distributed system like a layered service architecture, if you introduce a new NED, support for a new vendor, you want to be able to do that across your footprint. You want isolation, meaning that if someone touches parts of the network that doesn't overlap with others, you should be able to do things in parallel. And also here comes role-based access control, which can also be very powerful. With NSO, it's trivial to say, look, junior network engineers can only see customer-facing Ethernet interfaces. Only senior network engineers can see the IGP fabric, the internal routing protocols. Those are just means of expressing policy over the configuration sets defined by the Yang, right? So it's just a way of filtering what people can see. And of course, you need to be able to distribute across clusters. We have a whole HA story that we're not going to touch here today, but of course, your software upgrades need to work across hot HA pairs and things like that. Again, no surprises. That's kind of the thing here. And this is really cool to watch. We have a pretty stunning number of traditional network teams that are now running their automation tools in Jenkins or any other pipeline setup. GitLab CI and GitLab Runner seems to be a very popular choice. And this has been a very rapid development. Just a couple of years ago, I would have never thought that they would go so fast. This also means that as someone using NSO, you will start to see that you create new assets, right? You need to verify them, and then you package and ship. So invariably, our customers go to something that looks like a traditional software process, right? They usually use NSO installed on their laptop or their little development computer. And when they're done with their development, they push things into the pipeline that usually has a Docker or container-based set of verification steps. They then publish, depending on their deployment model, they publish the discrete packages themselves for manual installation, kind of an old school way of doing things, or as a VM for deployment, or as a set of UFS layers or a set of file system layers for Docker containers for those customers that are actually using Docker registries, or container registries, and they pull stuff into the network.
Does the pipeline do that? If I run it into a CI/CD, what am I doing? Checking to make sure that the parameters on the Linux VM that I'm creating to do FRR routing is actually inside tolerant? Is it using the corporate build? Is it that sort of a thing?
Kind of 3 layers.
Yeah.
First of all, it checks, right, this thing compile. It's just basic stuff,
okay,
right?
Yeah.
Does it lint? Does it pass? And actually, this part is usually a little broader and has 2 sides. The first side is, running this service, does the configuration that comes out of it, does it actually parse, does the device actually accept it? And the second half is normally, does that actually provoke the behavior, or does it actually affect the behavior the way I want it to? Right. So on the left side, you can have basic VM things, don't form relationships. Several of our customers are pretty advanced simulation environments, like a Viral 2 or a CML, I can't keep track of them, GNet, whatever they're called.
Whatever
these days,
the latest
right?
one is this week. Yeah.
Yeah, exactly. And to actually verify that the behavior of the system as a whole is correct.
Right, so you're actually saying, I'm building a POP, for example?
Yep.
And I'm going to deploy the whole thing in a simulator, and then I'm going to push a change to that simulator and say, does that adding that ACL actually add the ACL?
Exactly.
Or firewall rule? Or
right. Does that actually cut off traffic of the type that I wanted to?
Yeah.
And you do that in a continuous fashion, right? Mm-hmm. And if you're smart about it, again, you make a change to your service, maybe you add a couple of knobs to twist, and you just continuously run that. And then of course, well, again, this is not surprising to software people. You can trust that whatever you have on the loading dock here that goes into production, as far as you can see, actually works.
Your high level of confidence, yes.
High level of confidence. And the important maybe way to contrast this is traditionally this type of software has been more like a mainframe. So you have one, see what I mean? And everybody piles into it, and there's no distinct step of testing things. You just go straight into production, even in your automation step. This opens up again for a whole other way of doing it.
Yeah, because we've been working like startups for the last 30 years.
Yes.
There is only production.
There's only production. Exactly, right? And it is one.
And it's really unfunny to see us going back, packing away from being like genuine enterprise startups and actually going into test environments.
But there's so much to learn. That's what I think is so cool too. There's so much to learn from our application brethren here that just directly apply, which is really cool.
Provided you've got labs and runtime environments and
the look at some, in some operational management faces when their network engineer raises their hand and says, we need a GitLab license. They go, a Git what?
Oh, I was thinking of, product licenses to run in the lab.
Yeah.
Because licensing is turning into a nightmare.
I saw that on Twitter. Someone mentioned that on Twitter.
Yeah.
Yep. Closing thoughts. How are we on time?
5 minutes on time.
Awesome. Very good.
Well done.
So I don't know if, yeah. Here's what we also did, and this also excites me in a weird way. We spent so much time with customers doing things the wrong way that we've now packaged that into what we call the network automation delivery model. It's a set of very concrete codification of about 8 years of experience and wisdom watching some of the largest networks in the networking industry take their first steps into automation. And what's fun about it is that it's mostly about non-technical stuff. Many of our customers would describe their first journey with solutions like NSO or others, like coming home with your first baby. You don't exactly know what to do now. So you start, practicing practicing keeping the baby alive, and eventually you become a really great parent, hopefully really fast. I'm not going to go further down that path.
You'll be all right there, Omar.
Babies all around. So we've tried to help. We try to be the nanny here. So if you go and take a look at what we've built on that nice little URL here, you will find, again, a lot of the anti-patterns that we've seen customers inadvertently take on, codified and freely spread by us. And it literally comes down, well, there's a lot of things to say here, but we find there to be two very different phases in any automation journey. And believe you me, this is not at all one-to-one linked with NSO. It holds true for any automation platform or any automation tool. The first one is getting started. Just generally getting out the gates can be a very painful, almost traumatic experience for many of our customers. But when you've done that, you suddenly have a set of people that just did that actually understood what just happened. And then you can start scaling. And it becomes a chronological thing, right? But it includes things like, what's your strategy here? What is the definition of success? Does your manager's manager agree on the definition of success for automation, which can be a huge trip up, right? If you forget to anchor that, eventually there will be sad pandas all over the place because you think you did something awesome and all you get back is blank stares. So I highly, highly recommend looking at that stuff. We're trying to make it as concrete as we can without being too over-prescriptive. There's a lot of stuff. One of the things that we've also learned by integrating with the younger, if you like, generation and the software-centric generation is that easy access to everything is absolutely key. And coming out of an industry where you had to talk to a lot of people to get your hands on software, this has been a pretty interesting journey for us. So we've lined up quite a bit of material here. Of course, there's the entry-level stuff at Cisco.com. Our friends over at DevNet has a lot of resources related to NSO lined up. And we actually have a developer hub. This is interesting. So we now have on the order of maybe 200 to 300 people that does nothing in their working day except work for NSO. And lo and behold, they want to meet. They want to talk. They want to meet physically. So we actually have developer day conferences, people traveling to Stockholm in the summer, would you believe it? Or in New York in the fall. But we also have a pretty vibrant community online at this place, right?
It's a god-awful URL.
Oh, and you just made it way better by...
Look at you being all millennial. What?
Okay,
because again, this here is a journey, and any part of a good journey, of course, is to travel with people. Yeah. So we really have tried to line up all that good stuff for you guys here.
Can I ask you last question?
You can ask, and actually as many questions as you want. It's
so the free copy, does it mean that
yep.
almost everybody could start, testing the solution? Do you give all the plugins there and what are they called? The
NEDs.
The NEDs.
So everybody should. It is truly a cost-free download. So for your own training.
Yeah, non-production environment.
Exactly.
But,
just give us a ring.
But I don't need to buy you know,
That's
a
right.
month of
That's-
courses on
That's
stuff.
right.
So I can.
We love it when our customers download this, and when you get to the first meeting, they already have it on their laptops. See what I mean? That's the way we want this to be.
You're saying it's not limited?
It's not limited.
You're just trusting us
At
to
all.
call you
Yes.
when,
Truly.
hi,
The
I'm
amount
using it
of-
for reals now. I want
The
to pay
amount
for
of
it. Take
skin
my
off
money.
my back to keep that posture has been crazy over the years. We refuse to stray from that because, you know, that trust that I kept coming back to goes, bah.
So
we
talking
do
of
anything-
shirts on my back, did we talk about licensing and like what's the model for that?
We talked really briefly about it, and I was
Okay.
a little defensive, saying we've had historically a hard time figuring out how people want
Yeah.
to buy it. The closest we've come to a generic model is right to manage. It's subscription based, so right to manage, size of the network, and number of different platforms. Don't give me that face. If you don't like that,
It's the one I've got.
is there something on the back of the no? But again, you know, it is
Yeah.
an emerging type of solution. So people have very strong opinions, and we are working on various ways of making it more flexible. We're just trying to find the way.
Because I want to see this in enterprise. But
So do I.
like
Give me some
two
advice.
years ago or so, NSO was not ready to go into enterprise. It wasn't, I mean,
Galaxy?
the BU wasn't ready to sell it into enterprise. There wasn't,
We are
So
about
I'm-
1/3 of our incoming new business now is enterprise.
yeah. Because I love the product.
Thank you.
I
Appreciate it.
I loved it from when it was tail-F.
Awesome.
Really clever stuff.
Fantastic.
Yeah, and one of the things we're working on is, I mean, the licensing's improved both for service provider and enterprise. We're working on better licensing models, and certainly we know for enterprise it's not our SP model doesn't work well. So it's a work in progress.
Yeah, we're a bit smaller. We're a bit smaller.
It
Most-
should,
well,
it
no,
should, it should
most-
scale down.
But yeah, I mean, that's we're working on the ability to scale down too. So.
Yeah. Cool. Thank you.
Thank you.